Kia ora everyone, here I am with the 2024, I said that in the last video, TGC derived grade exam for level 3 chemistry. This is the organic paper and this is the last question in the paper, question 3. And here we have a very simple naming and drawing, and I did note that some of you didn't do this, and actually that's fine if you're pretty confident with yourself. I don't recommend that you ignore your naming and drawing, but in this table, as you know, it's only going to be an achieved, possibly a merit if they're struggling to find marks, and there's a couple of tricky ones in here, but let's go through it anyway. Most of you did a really good job. 3 bromohexanamide. So we've got a hex, 1, 2, 3, 4, 5, 6. We've got an amide, so that's going to be CONH2 on the first carbon. That makes that carbon 1, 2, 3. So we have to put a bromo off 3. I'm not going to draw all the H's in just for time, but if it was an exam I would, but not on that one. Right, this one here, I've got this lovely ester group, so I know my ester is going to be something and something anoate. So the anoate comes from the bit with the double bonded, the carbonyl group here, so that's 1, 2, 3, propanoate. And the il comes from this side with the single bonded O, so that's eth. So ethyl propanoate there. 2,2-dimethyl-butanoyl chloride, so starting with the bute for 4 carbons. Anoyl chloride is an acyl chloride, which looks like that. So that now has to be carbon 1. So therefore we need on carbon 2, which is this one here, we need 2 methyl groups. So CH3 and a CH3. And then I'm just going to complete all my hydrogen. So each carbon has 4 bonds. And the last one here, my longest carbon chain is a bute. I've got 2 different functional groups. I've got an amine and an alcohol. And in level 3 at school, you can name them whichever way you like. We are going to have a 1 and a 3. But whether you put which one you use for the word ending and for the prefix is up to you. So I'm going to go 3 amino, bute, and 1 ol. But you could have gone 1 hydroxy, bute, and 3 amine, I think would have been fine as well. But I think this is the best name for it. All right, going over the page now, 2 bits left. We have got compounds A to D and we need to distinguish. So we've got an alcohol here. We've got an acyl chloride here. We've got an amine here. And we've got an amide here. That's pretty kind of standard set of compounds. We have got water, red and blue litmus, and we've got aqueous acidified permanganate. When you've got an acyl chloride, you need to start with water. If you start with permanganate, like a few of you did, you must recognise that as well as the purple change in colour, it is aqueous, so it is going to do the water reaction with acyl chloride anyway, and if you don't recognise that, you're not going to get full marks, and that would be a pity. So let's start with adding water to a sample of all 4. And we need to make sure that we have all of our observations positive and negative. Okay, we've got 1 will react. Most of us got this. React violently, vigorously, with bubbles. And they love their steamy fumes. I always just say white fumes of HCl. The other 3 will not fizz or fume. The one that reacts is B. And let's have a look at what we need to do. Observations. Identified of type of reaction. Okay, in a substitution reaction, You could also call it a hydrolysis reaction since it's reacting with water. Those are the best two. And structural formula of any organic products. So we need to faithfully copy the carbons to form, let's go, CH3, CH, CH3, and then of course we are going to have a carboxylic acid group there. Okay, so to the remaining three, it doesn't really matter what you do from here on, I mean the order, to a sample of the remaining three, add, I'm going to do the permanganate here, MnO4 minus H plus, one sample decolorizes the purple permanganate. Please remember that it's the permanganate that's decolorizing, not the alcohol, permanganate. The other two remain purple. The one that reacts is the alcohol in an oxidation reaction to form, and let's do the product now, so keeping the same carbon chain, I've got 4 carbons and my alcohol is on carbon 2, so 2, 3, 4, and so that is going to get oxidized to a ketone. Just be careful not to put an H in there. A ketone, let's put a ketone there, and let's put a carboxylic acid there. It doesn't ask you to name anything, so unless it's an easy name, I probably, ethanol to ethanoic acid, I probably wouldn't bother with that. Right, so I've only got C and D left now. I've got an amine and an amide, and this is a little bit tricky, I get that. So you've got to have some way to remember that your amine is the base and your amide is not the base. So to the remaining two, add wet, what am I looking for? Red litmus. Has to be wet. One turns the litmus blue. The other does not change the litmus. Does not, gosh, I'm ahead of myself, sorry. Change the litmus. Okay, C is the base. This is an acid-base reaction. A few of you just fell over a little bit at the end here. Forming, and it's just an acid base, so we're just going to remember what bases do. They accept protons. So we do need to keep our 3 carbons and have our NH3 plus on that carbon there. Right. So there we go. So that's why we need the water, remember, so that the base can accept the proton, and that's what's going to generate the OH minus ions to actually change the colour of the red litmus. So have I got them all? Have I got 3 structural? Yes. Have I got reaction types? Acid base, oxidation, and substitution. Great. So I'm good to go there. And the final question in the paper, this was a tricky one, and actually a lot of you did quite a good job here. Some of you just haven't quite, you don't quite check back with yourself, I guess. And so remembering that compound U has to have 5 carbons. And unless we make an ester or we hydrolyze something, we're not going to change that. So let's just draw our 5 carbons in for U. So it's straight chain, so I've done that. It exists as enantiomers, so it's got to have a chiral carbon, and it's got geometric isomers, so that means it's got to have a carbon-carbon double bond, and we've got to have some 2 different atoms or atom groups coming off each of those double bonded carbons. Then we have got reacts with acidified dichromate to form V, which does not. So that means it can get oxidized, and I think that's meaning that it's going to be an alcohol group. But if it does not react with Tollens or Benedict's, that's telling us that it's a ketone. So actually we need to have a secondary alcohol in here. So I'm going to put the alcohol on this carbon. It could have been on any one, and sometimes I might need to try something and go back. It rapidly decolorizes. Okay, so these are all carbon double bond to carbon, carbon double bond to carbon. So let's just put our carbon double bond in. And if I put my carbon double bond here, that's going to be wrong because it won't form geometric isomers because it'll have two H's there. So what I'm going to do is I'm going to put it here. Okay, and in fact there might be more than one place you could have put this, but I think this is probably the best one. And what we get here is, let's just count our hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that looks like it could be a good answer. U then gets oxidized to form V. So V is going to have the same 5. It's still going to have that double bond, but this carbon is going to be oxidized to that one there. So let's just 1, 2, 3, 4, 5 keep that in there. Okay, so that's going to be your V. Then U reacts with bromine water to form W. So here's my W. So bromine water doesn't affect the OH, but it is going to add across both of those carbons in the double bond. So there it is there. U reacts with hydrogen to form X. So down here we're just going to hydrogenate that. So we're going to keep my OH there. And we are going to just saturate this molecule here. Of course, you'd be drawing your hydrogens in. Right, so compound X reacts with conc H2SO4 to form these two here. So we're going to remove the functional group and either this adjacent hydrogen or this. So one of them's going to have the double bond in 1 and one of them's going to have the double bond in 2. And we're removing, so the pore gets poorer for the major. This adjacent carbon is poorer. So the major, which goes in Z, is going to have the double bond between carbons 2 and 3. And the minor is going to have the double bond between carbons 1 and 2. Just make sure you check those hydrogens carefully. And that's it. Right, so that is the end of the paper. So well done to all of those of you who had a good crack at it. And I hope that you feel a bit more confident as you go into your NZQA exams and beyond. Haere rā, see you for the next paper soon.